hand over to you. Thank you so much.
It's supposed to be a slide. OK, very well. I'm the guy who is standing between the talks and the drinks, which is very difficult. There are actually two slots in conferences like that. The first one is the 2 o'clock slot, which is the post-burrito coma, and the other one is this one just before the drink. So let's go quick and fast. OK. So I'm Frederic. I started the Deepnews.ai when I was at Stanford. I was a fellow at the John S. Knight Journalism Fellowships. And after that, I spent an extra year at Stanford doing a research fellowship precisely on this thing. So what do we do at Deepnews.ai? What we do is we reverse engineer journalism. We have been fighting for this baseline for quite a while with my team. They believe it is a completely stupid and silly and bad baseline, so I leave that up to you. But this is basically the truth. We built an algorithm that detects structures and patterns that convey the notion of good quality journalism. This is what we are doing. What we are doing is that we find the building blocks of quality journalism, and we work with mathematicians, natural language processing people, deep learning specialists, and we put that into, we modeled that. We give publishers new tools to predict the performance of their content, whether their business model is advertising or a subscription. So how Deep News works, very basically. Let's say you are a publisher or a news aggregator. You submit your stories to our algorithm, and it returns a score, a quality score. It is as simple, and believe me, it is as complicated as that. So we assess the quality at the article level. And by quality, I will come back to the notion of what we mean by quality. We do that at the article level means that we are the only one right now to do that at this level. Right now, you have plenty of very competent news organizations which look at the quality, the general quality of a media versus another one. We decided to do that at the level of the story. What we do is that we provide content-based analytics for publishers. Let me explain. What we mean by quality score is we try to measure the amount of resources deployed by a media organization to cover the news, whether it is a notion of value added, long story versus short story, but not only, because we will come back about the notion of length of a story. We measure we would like to measure the workforce which is behind a story. We'd like to measure the level of expertise. We'd like to measure the notion such as elusive and intuitive notions such as talent. We'd like to measure the ability for a news team to work in an innovative way, to have a different approach. So what lies under the hood? And this is going to be a little bit technical. We use deep learning algorithm, and the whole idea is to find hidden patterns that will draw clusters of editorial quality. It's a black box, but I'm going to explain what we try to have behind that. I'm not sure you are able to see. Yeah, here is the journey of a story which enter our algorithm. So this is a story of The Guardian, so we get the URL of the story. Then we get the HTML, of course. We extract the text. We do further refinement on the text. For instance, in some example, we are going to remove the named entities, means the name of people, place, figures, and stuff. Because funnily enough, what we found out is our algorithm is better at detecting the quality, as being good at detecting the quality for stories which are stripped down of any element of information, so to speak, like name entities. It worked well that way because, again, we are working on the very atomic structure of the story. Then we vectorize this stuff. We use public domain tools. One of them has been developed by Stanford. This is actually a rendering of stuff. It's called GLOVE, to transform stories, to transform text into numerical values, because deep learning models are not able to ingest text. They are only able to ingest numbers. So we put that into what we call a convolutional neural network. A convnet, as it is called, are usually used in machine and deep learning for image recognition. They are fed with tons of images. When I mean by tons of images, they are fed sometimes by millions of images, and the network is shown an image it has never seen before and is able to tell if it is a giraffe, an animal, or whatever, or something like that. So we do the same thing with stories. And we get the score, and the whole process, once it's in operation, could take less than 100 milliseconds. This is what we do. The very structure of the model, this is the least sexy slide you might have during this presentation. I'm sorry about it, but I think it's interesting to see what is really under the hood here. Here you have a representation of the very structure of the model. A deep learning model is a stuff which is filled with weight. For the French audience, it's called pondération, which is a value which is going to express a difference of something versus another. We have 20 million of these kind of parameters. It means that basically the model is going to look at a story through its own grid of 25 million parameters, which has its upside and its downside. The downside, which is often a criticism for deep learning stuff, is that it is actually a black box. Even us, we are having hard time to find out what the model actually sees. We are not exactly sure what the model is looking at. We have some kind of clues. We believe, for instance, that it's looking at punctuation, is looking at grammatical structure, is going to look at the length of sentences. But the combination, the real combination that will lead to a score is totally mysterious. This is the downside. But it has an upside, which is it's a model which is absolutely impossible to tamper with and to reverse engineer. If someone would be willing to do that, it would require significant talent of mathematical people and significant computational power, because we trained this model. We made 55 versions of it. By the end of the year, we will have 80 versions of different models. We tweak the stuff all the time. And it required 1,500 hours of training on Google Cloud. So right now, the model has 85% of accuracy. It means that in 85% of the case, it is able to recognize a story it has never seen before and assign a score, which is a fairly good one. How we measure that? We actually fed the model with tons of articles, thousands and thousands of articles, a few hundred of thousands. We took some samples that we give to humans. Actually, we give several thousands of stories to journalism students. We paid for them, and we asked them to score the story. We did some statistical stuff in order to have some kind of reliability in the statistics, and we add a data set that we expanded through a technique called transfer learning, which is basically expanding a data set, and now we have a fairly large corpus. We are able to train the model, and the model is learning on the thing. So this is, it works. So the roadmap is the following. The first product we have, actually we are launching, I wanted to launch it before the Gen, so it was kind of a deadline for us. It's called Deep News Digest. It's a very straightforward product. It's a newsletter. Right now it's a weekly newsletter, which is free, which is a series of links on a given subject. For instance, last week we did the soccer women's soccer cup. And tomorrow, not tomorrow, but we decided today that we are going to do stuff about Hong Kong unrest. And so you will get a list of 50, first of all, in the first version we have 100, but it was a bit too much, 50 links that are ranked by the quality we decided they have. Actually, the algorithm decided they have. So the whole idea is to have a unique story. You won't be overwhelmed by tons of stories saying the same stuff. You will have a unique stories on a per subject, on an angle, a precise angle that will be in this listing. So you should subscribe because it's free. And you should also subscribe because actually my dream would be to have some collaboration with people like you guys And at some point, we might be even open to do some kind of bespoke newsletter for your publication, for free, of course, because we need to understand, we need to learn what's going on. So it's a alpha version of it, it's a beta version of it. We'd like to refine with your collaboration. Okay, so the score, which is at the core of the thing. The score has multiple applications. The first one, which is the most important, business-wise, is advertising. We live in an absurd business right now in which, regardless of the quality of a story, the advertising which sits next to the story, the price of this advertising won't change. Whether the story, it is a news wrap-up put together by a couple of interns, or a long-form article which requires 3 weeks of work by a whole bunch of reporters and editors. The price of the advertising will remain the same. So, in our view, if we are able to come up with some kind of gauge, some kind of label that will say, oh, this story is worth 4.5 out of 5 versus this one which is only worth 1 point, we should be able to be in a position in which the ad server could be able to serve an advertising in accordance to the quality of the story, which could completely change the economics of the business. So that's for the advertising stuff. The other thing is recommendation engine. Recommendation engine is a hugely important stuff in our business. First of all, I mean, there are some other business in which it drives the actual consumption of things. For instance, Netflix, 85% of what you watch on Netflix is driven by recommendation engine. On YouTube, it's even higher than that. And I never met a publisher who is happy with his or her recommendation engine. Basically, it sucks everywhere. So we need to do something about it. The other thing is aggregation. If you are having some kind of business of aggregation, you get stories from a lot of sources. It's great to have a way to actually being able to score the stories, to rank them, and to find the most valuable stories. And the other thing is personalization. Okay, I need to move faster because the clock is ticking. What we have built, we built a performance predictor for publishers, aggregators, new distributors, advertisers. We are building a system that finds correlation between our score, the Deep News score, and all of the indicators that a client, my customer, might find relevant for his business. So here is what we get from our own model. We get this, which is, most important is the column in the middle, which is the score we get. We have the idea of the article, we have the URL, we have the title, we have a couple of indicators, and we get the score for the story. So this is what we get internally. And here is what we propose to offer to publisher, which is a kind of dashboard in which the publisher will have the same data, but also we might be able to predict a lot of relevant data. We are not going to measure data afterwards. We might be able to say, okay, the story number 877, which ranks 4.56 on our stuff, which is a very good score, by the way. It might have a time span of X, a reading completion of 78%, a revenue per page of X, etc., etc. We build a predictive model of the performance of the story in your framework. This is what we are doing. So the pipeline we like to offer to publisher right now is a publisher will give us some metadata under a strict NDA. Confidentiality is key. We will process the metadata, and we will train the algorithm, and we will crunch the number for it, and we will store the data in a silo, and it will be the publisher's silo, no one else who have any access, and we would like, of course, to do that to a whole bunch of publishers, because what we would like to do is we would like to learn from the data of everybody else without, again, without in total segregation of each publisher's data, obviously, okay? So, right now we are in the research phase. The whole stuff is absolutely free. I'm not selling anything. There are two ways. Either a publisher gives us some data, we train the model, we compare if are we able or not to predict some kind of key indicators for the publisher. Option A, it's inconclusive, it doesn't work. It could not work for many reasons. The first one is that, in fact, we would need to build lots of models for different stuff. And the other reason is that under certain circumstances, the model works better than others. For instance, we know that it doesn't work extremely well for sports stories, or entertainment stories, or food critics. The model doesn't work well because it has not been trained that way. It could be trained, but actually it doesn't work. So, I mean, if it doesn't work, I mean, we part ways, and we might do business later on. Also, it could be conclusive. In that way, what we propose is to build an API. I mean, again, the publisher, the whole goal of this thing is to be a positive contribution to the sustainability of the news ecosystem and to the sustainability of a publisher's operation. This is what we do. So if it works, if the publisher decided, okay, your predictive capabilities are actually not bullshit, I mean, it works for good, we might be able to build an API, an application programming interface for the publisher, and we're doing some kind of deal in which he will have access to his data. He will create streams of his article, rank, predicted, and so on and so forth. So that's why we need to work with you guys. We need to have more partners in order to have more data. Most of them will be totally anonymized, neutralized, and stored securely, and so on and so forth. Because the whole idea, again, is to increase the value of quality news, which is very important for the future, not only of our business, but for democracy as a whole. Thank you very much. Thank you. Go to Deepnews.ai, subscribe to the, you can subscribe to the Monday Note, which is free. I'm on the free business, actually. And again, I mean, we're not going to take questions right now because I suspect that everybody is impatient to
We're not going to take questions for two reasons.
Huh?
One, there are a bunch of opera singers backstage who are apparently about to do a rehearsal, so we're going to get kicked off. And two, because you're going upstairs for drinks, I believe.
Yes, I mean, it's boozing time. Thank you for your time. Thank you.
Thank you so much, Frederic. Really appreciate that. It was a great session. So just quickly, before you all head upstairs for drinks, because I know we're all dying to do that, very, very quickly, tomorrow morning we have got